Well, if you ask me what's the best way to start doing your math homework, very easy. Just dive into it. I'll show you. One, two, three. Woo! Just like that.
Good day, everybody. Let's dive right into this lesson. Today, we are once again talking about central tendency and data. We will be reviewing the quartiles, quartile 1, quartile 3, the median, and the interquartile range. We will also be taking a look at your last vocabulary terms that we are going to be looking as far as data is concerned. And that is, we're going to be looking at something called variance. And then once we find the variance, we're going to take the square root of the variance and we will end up with the standard deviation. But in order for us to find the variance, we first have to find the mean. So remember, mean, variance, standard deviation. Mean, then variance, and then the standard deviation. You're going to first find the mean, and then you're going to find the variance using the mean, and then you're going to press the square root button, and then you'll get the standard deviation. As far as the formula is concerned for variance and for standard deviation, it'll be on the bottom of your notes. However, it's kind of difficult to understand, which is why we're doing a lesson for you today, right? Basically, to find the standard deviation, you're going to first find the variance, and then you're going to hit the square root button, and it'll tell you what the standard deviation is. But in order for you to find the variance, we first have to find the mean, subtract each number, square it, and add them. That's why there's a sigma here that says the sum of. Okay, don't worry too much about the formulas. I will show you how to use them. So, like I said, let's dive right into the assignment. Which assignment, you might be asking? Well, remember, we are doing measurement and spread this week. So I'm going to help you with all of letter A, and then you'll be going and doing letter B. So let's take a look at question number 1. Question number 1, and like the first 4 or 5 are really, really simple, is basically going to give you a keyword to find the range. You remember that in order for us to find the range, you got to first find the low number and the high number and do what with them? That's right. Just simply subtract them. So if you take a look at your data, you're going to see that there's a table there with a lot of numbers. And of course, you're going to find out that the lowest one is 29 and the highest one is 48. And the keyword is range. So what am I going to do? Just simply subtract. The range is the high minus the low. When you subtract, you end up with 19. So now that you know how to do the range, go ahead and try number 2. Take a look at number 2. You'll see there's a table right there for you. You'll see that the highest one is 30 and the lowest one is 2. Therefore, once again, if the highest one is 30 and the lowest one is 2, then the range is 28. That takes care of numbers 1 and 2. Very well. Let's go take a look at number 3, right? So here is number 3. It says for you to take a look at all these numbers, and then they want you to calculate the mean and calculate the range. Well, we just practiced on that, right? So let's go over and find the mean. Remember that to find the mean, all you got to do is cancel the high, the low, the high, the low, the high, the low, the high, the low, and you will end up with a mean of, oh no, that was the median, huh? Boy, I was wrong. You don't cross out the high and the low. You add them all. That's right. This is the mean average. So once you add all of these numbers here, you'll end up with 135 divided by 9, which is 15. Now, let me go a little bit into the story. If you read the question, it says that Corey is a basketball player, right? A basketball player. And on his first game, he scored 56 points. You would have thought he was like Michael Jordan, right? So you're thinking, wow, this is a superstar player. But then the next game, he only scored 18, so he had a bad game. But then he had 1 point. Oh my God, that's a horrible game. And then 11 and 7 and 7 and 14, he came back to earth. And so based on your judgment, your first game, you would have thought, man, this guy's a superstar. But not really, as you can see, right? He just had a very, very good game. When you calculate the mean by adding all those numbers and dividing by 9, you will get a mean of 15. Okay, 15 compared to all of those, that's only Two of the scores are higher than 15. The others are not. Let's go calculate the range. Well, the range is the highest and the lowest. So the highest is 56. That's his good game. And the lowest is 1. That's his low game. And therefore, the range is 55, which is 56 take away 1. So now you're going to read through the answers there, 1, 2, 3, and 4, and you're going to see that number 1 is correct because the mean is unusually high compared to most of the data points. 15 is higher than all of these. So number 1 is true. Number 2, the mean is unusually low. No, it's not. It's higher than all of those. So number 2 is not right. Number 3, the range tells the total number of points Corey scored in the past 9 games. That's not true. That's the sum of all of them. The range tells the difference between the highest and the lowest. So 3 is not. And finally 4, the range gives a better indication of Corey's consistency, which as you can see, he's not very consistent, right? That is why the answer is 1 and 4. And if you look for 1 and 4, it will be letter D. This is just trying to understand what data tells you, right? Okay, 3. Number 4. So we're going to turn the page here. We're going to take a look at number 4. And when you go to number 4, the key word is the range. Well, we already know how to do that. Just go look for the highest one, 61.3. Go look for the lowest one, 19.3. And if you subtract, you will end up with a range of 42. Like I said, first 4 or 5 are really, really simple. Let's go take a look at number 5. The key word is the upper extreme. Well, upper means high, and extreme is, which one is, of all of those, is the extremely highest point, or the highest. The highest point is 48, and so upper extreme is 48. Take a look at number 6. What's the key word? Lower extreme. Okay, well, lower extreme means which one is the lowest number. And if you take a look at all the numbers that number 6 gives you, it is 13. Okay, this here is number 6. Number 6 is the lower extreme. Number 5 was the high upper extreme. Okay, so there's your data points. I didn't write them down for you, but you can clearly see that the lowest of all of those numbers is 13. Now, number 7, you've got to remember the way to read a stem and leaf plot, right? And that is that you're going to take a look at your tens digit here. So what this really means is 42, 50, 58, 59. There's nothing in the 60s, nothing in the 70s, nothing in the 80s, 90, 92, 92, and 96. Okay? So that's how you read it. What is its keyword? Lower extreme. In other words, what's the lowest number? And of course, the lowest number here is 42, because it is, in fact, the lowest number. All right, there's number 7. Number 8 is another stem and leaf plot. So this table here shows you, except now you have 2 digits over here. So what this really means is 172, 173, 178, 180. This is 220. That's the way you read it. Okay, so now, what's the key word? The upper quartile. Oh my goodness gracious. All right, so now we got to go and review what the median is, the upper quartile and the lower quartile, right? So, a couple of ways to do this. Number 1 is you can write down all the numbers from the smallest to the largest, which is what I did here. I wrote 172, 173, 178, 180, 194, 197, 204, 208, 210, 211, 214, and 220. Now, if you go look for the one right smack in the middle, of course, that would be your median. And so it would be right smack into there. So then to find your median, it's the point between 197 and 204. All right. To find Q1, the lower quartile, you would then take a look at the lower 6 numbers, 1, 2, 3, 4, 5, 6. And you would go find the one where it's right smack in the middle, and you would find the number that is right here, which is the number between 178 and 180. That would be 179. That would be the lower quartile. But the key word was upper quartile. So don't look at the lower set of data. Take a look at the upper set of data. So you would take a look at these 6 numbers, and you would cross out the high, the low, the high, the low, the high, the low, and you would find a number that is right smack right in here between 210 and 211. The rightful answer is 210.5, which is not there. And so you would just answer the question to be 210 because we haven't reached 211 yet. But it is 210.5. Alrighty. There is another method if you don't want to write down all the numbers. And that is for you to use the formula that was given to you. The formula that was given to you was Q3 is 3/4. Q1 is 1/4 of n plus 1. So all you got to do is count the amount of numbers up here or down here. And you'll see that there's 12 numbers. 12 plus 1 is 13 times 3 divided by 4 is 9.75. So now start at the lowest number and count until the 9th number. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you end up with 210 right there. That's the upper quartile. Or you can go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the upper quartile is that guy right there. 210. Okay? So let's see, this time they want the lower quartile. So now we're going to go over and look at number 9. And it says that there are 30 students. Imagine having to write 30 numbers. Well, you can if you wish. I started to. 3, if you look at the frequency table there for question number 9, let me switch the page. It says that there's one score of 3, 0 scores of 4, 4 scores of 5. That's why I have 1, 2, 3, and 4. 2 scores of 6, 3 scores of 6, and then 7, 12 scores of 7. So you can write all 30 numbers if you want, but you shouldn't have to. If it's the keyword is the lower quartile, Q1, then you're just going to use the formula here, which is 1/4 of n plus 1. Plug in 30 right there. And you get 31 divided by 4, and you end up with 7.75. What does that mean? I'm looking for the 7th number. Alrighty, 1, 2, 3, 4, 5, 6, 7. That is why the lower quartile is 6. Okay? Wonderful. Okay, those were not that bad. Here's the new stuff. Keyword, variance. Remember what I said earlier about variance. You first have to find the mean, and then the variance, and then the standard deviation, if that's what they're asking. So, first, we're going to go find the mean. Okay? If you find the mean and you add up all of those percents, by the way, number 10 is a table that looks like this. Here's your percents. I know that there's chemistry, physics, and biology, but of course, here we are in a math class, so we're going to focus only the math scores, okay? Which are the better scores, by the way, because there's 2 A's in there. Yay, math! Okay, so I found the mean by adding all of those numbers, 407 divided by 1, 2, 3, 4, 5, and the mean is 81.4. Now, I realize that this question, because of the decimal, is going to be a little bit harder. You're going to need your calculator. Why? Because I need for you to subtract and square, okay? And then add. Subtract, square, and add. Subtract, square, and add. In other words, get this number, take away 72. Get the mean, subtract 72, and square it. And here's what you're going to get. Now, here's a formula for variance, okay? You're going to get the number, take away the mean, and then square it. And then at the end, we're going to divide by 5, okay? And that's going to give me the variance. Okay, now they're all going to be decimals. Hang in there. All righty. One more time. I'm going to get 81.4, take away 72, and square it. And you get 88.36. Then do it again 4 more times. Get 81.4, take away 63, and square it. You get 338.56. Do it again 3 more times. 81.4, take away 88, and square it. You'll get 43.56. Do it 2 more times. 81.4, take away 94, and square it. You get 158.76. 81.4, take away 90, and square it. 73.96. There's all your 5 sums. And now you're going to divide by 5. And your variance is, after you add all of that and divide by 5, 140.6. Okay? That's number 10. I'm going to keep that to the side over here because I'll be back for that. Let's do it again, but this time no decimals, okay? Nicer. Number 11. If you read number 11, the key word is once again variance. Here are the numbers they give you: 28, 26, 33, 41, and 47. Remember, you're going to find the mean, then the variance, and then the standard deviation. Okay? But here they only want you to stop at variance, so don't go to standard deviation yet. Okay. So I'm going to go find the mean by adding all those numbers and dividing by 5. Here we go. Add them all up. 175 divided by 5 is 35. There's your mean. Okay? Now I'm going to use the formula which says get the mean, take it away from the number, and square it. Okay, it doesn't really matter which of the two numbers you put first or second, because when you square, it's going to end up being a positive number anyway. So, let's go do that. 35, take away 28, and square it. What does that give me? 7 squared is 49. 35, take away 26. Well, that's 9. Square it. That's 81. 35, take away 33. That's 2. Square it is 4. 35, take away 41. That's 6. Square it is 36. 35, take away 47. That's 12. Square it is 144. Add up all those numbers. Take this divided by 5. And there is your variance. Had I asked for the standard deviation, I would just take the square root of that and then I'm done. But I haven't taught you that yet, huh? That's okay. It's coming. Oh my God, there it is right there, standard deviation. Okay, so remember, standard deviation. You find the mean, the variance, and then you square root it, and then you get the standard deviation. Mean, variance, and standard deviation in that order. Here we go again. Except I got to do it all those times. Oh my goodness gracious. Let me go find the mean. Once I find the mean, I'm going to go to variance and I'm going to go to standard deviation. Okay, so to find the mean, you add all those numbers, you divide by 10 numbers, which is going to give you 36. Okay, and now I'm going to go find the variance. 36 take away 45 and square it, that's 9 squared is 81. 36 take away 48, that's 12 squared is 144. 36 take away 25, 11 squared is 121. 36 take away 37, that's 1 squared is 1. 36 take away 40, that's 4 squared is 16. Do it again, 4 squared is 16. 36 take away 41 is 11, 121, and then 25 and 4 and 49. When you add all of those numbers, that's 578. When you divide by the amount of numbers, which was 10, you get 57.8. This is the variance. So how do we find the standard deviation? You go to your calculator, you hit the square root button, and that is your standard deviation, which is 7.6. Now you're going to need standard deviation for next week's lesson on the normal curve. So we need to know how to find the standard deviation manually, okay? Here we go again. Keyword standard deviation. Obviously, this is going to be an easier question because there's only 5 numbers, right? What was the order again? Mean, variance, standard deviation. In that order. Okay, here we go. Let me go first, add all of those numbers and divide by 5. The mean is 35. Okay, now remember, subtract, square, and add. Subtract, square, and add. Subtract, square, and add. Okay, here we go. Notice how we travel in threes, huh? Subtract, square, and add. Mean, variance, standard deviation. Oh, it's nice to be in threes, I know. Okay, here we go. 35 take away 28, that's 7. Squared is 49. 35 take away 26, that's 9. Squared is 81. 35 take away 33, that's 2. Squared is 4. 35 take away 41, that's 6. Squared is 36. 35 take away 47 is 12. Squared is 144. Divided by the 5 numbers, and you get your variance of 62.8. From variance to standard deviation, all you got to do is hit the square root button, and then kaboom! There's your standard deviation. Okay? Turn the page, and here's our last page. We are almost done, huh? Let's see, number 14. Number 14 is going to ask you to refer back to the table in question number 10. This is exactly the same as number 10. So on your paper, write, refer to question 10, number 10. So let me bring it back, because this time in question 14, it's asking for the standard deviation. No, you don't have to do all the work again, because when we did number 10, we had already calculated the variance to be 140.6. So how do we get from variance to standard deviation? Yep, you got that right. You just hit the square root button. So you're going to refer to question number 10, because we already know that that's the variance. Hit the square root button, and you get 11.85. Now, why did we learn all of this? Standard deviation only to get you ready for next week, which means that now you can go back and do page 3. On the extra credit packet, remember how I told you to skip everything that had to do with standard deviation? Now you can go back to page 3 of the extra credit and do anything that says standard deviation, because now you've learned it. Okay, here we go. So, in question number 15, they're going to give you 6 numbers: 0, 2, 4, 6, 7, and 8. 0, 2, 4, 6, 7, and 8. And how do we find standard deviation? You first find the mean, and then the variance, and then the standard deviation, right? Let's go do that. So I'm going to add up all those numbers. You get 27. Divided by 6 numbers, you get 4.5. There's my mean. And then I'm going to go find the variance. So to find the variance, remember, you subtract, square, and add. So 4.5, take away 0 is 4.5. When you square it, you get this number. 4.5, take away 2. You get this. When you square it, you get this number. And then 4.5, take away the next number, which is 6. When you square it, you'll get here, okay? So you're going to add up all of those numbers and divide it by 6. And you'll end up with your variance to be the square root of 7.9, which is 2.8. Now this, we've already done. Mean, variance, and standard deviation. Just do it one more time. But let me give you a preview, just like when we used to go to the movies. They give you a preview of what's to come. Why is standard deviation important? Well, this question is giving you a preview of what's to come next week, okay? Next week, we're going to be looking into something called the normal curve. The normal curve, obviously, is in your notes. It's in the back. It's this normal curve thingy here. And each one of these lines here is called one standard deviation, okay? But that's for next week. Let me continue with my preview here, because the question is, how many of these numbers, 0, 2, 4, 6, 7, and 8, are within 2 standard deviations? So, ta-da! Let me unveil the normal curve. Voila! This here is the normal curve. The line right smack in the middle is the guy that's going to give you your mean, which is, of course, 4.5. And there's your 4.5. Now, you are now going to add and subtract one standard deviation. Obviously, just like the number line, when you add it to the right. When you subtract it to the left. When you add one standard deviation plus one SD, that's this line. When you add 2 standard deviations, that's this line here. Now remember, this curve is the normal curve. This is 100% of any data, like population, for example. So this is 100%. That means the right-hand side is 50%, and the left-hand side is the other 50%. And each of these little lines is one standard deviation from the middle. Okay, so I'm going to add the 4.5, which was my mean. No, I'm going to add the 2.8, which was my standard deviation. My mean is 4.5, which is where I'm going to start from. So here's my mean of 4.5. When you add 2.8, you get 7.3. When you add another 2.8, you get 10.1. That's one standard deviation, 2 standard deviations. Now I'm going to subtract. 4.5 take away 2.8 is 1.7. 1.7 take away 2.8 is negative 1.1. So these are your standard deviation lines. Once again, this line here is one standard deviation. This is 2 standard deviations. One standard deviation to the left, 2 standard deviations to the left. The question was, from these 6 numbers, 0, 2, 4, 6, 7, and 8. From these 6 numbers, how many are 2 standard deviations away? Okay, now I'm going to plot those numbers right there. 0, 2, 4, 6, 7, and 8. Okay, 0 is between negative 1.1 and 1.7. It would be right smack right there somewhere. 2 is a little bit to the right of 1.7, which would be right there. 4 is right before 4.5. 6 is right after 4.5. 7 is right before 7.3. And 8 is after 7.3. So if I was to ask you how many of these numbers are within one standard deviation, that would be that. The answer would be 1, 2, 3, 4. However, the question was how many are within 2 standard deviations? So 1, 2, 3, 4, 5, 6. All 6 of my numbers are within 2 standard deviations of the mean. Okay? That's what we're going to be doing next week. This is why variance is important, so you can then find the standard deviation. Okay? Standard deviation is very important. Okay? Remember that we have tutorials, so please visit us at our tutorials should you have trouble. Of course, now your homework will be for you to start working on letter B, since I already did all of A for you. And then move on into your reviews. At the end of your packet, there's review A, there's review B. You can now do everything up until standard deviation. But anything that has to do with the normal curve or Z tables, just wait till next week, okay? Until then, this is Mr. G signing out. Later days. Bye.